Okay, so last time in the last video, we talked about respiration, which comes from the saprotrophic bacteria from the plants and the animals and how those contribute to the atmospheric pool. And so for a second, we're going to focus here on the anaerobic respiration because both the saprotrophic bacteria, the plants, and the animals, when they're doing respiration, they are using oxygen to do so, but there's a separate class of bacteria, these methanogens, our friends the Archaea, who conduct this in anaerobic conditions, so no oxygen or low oxygen conditions. So, as their name suggests, they produce methane, and so this is all occurring in places where you have a lot of organic material, but there is no oxygen present. So the important thing is this is anaerobic. That's what anaerobic means. It's just no oxygen, right? And so there are lots of places on the planet that have these sort of characteristics. So things like wetlands or bogs or swamps or inside the intestinal tracts of this cow who's having like a super fart, any sediments or landfills. So you have a lot of that extra organic matter, but there's no oxygen present. So a certain class of bacteria, a certain class of the Archaea, will thrive in these conditions, and so they produce methane, and so they are known as the methanogens. And so these guys will take carbon dioxide that's around, and again, because there's no oxygen, so they take the carbon dioxide with some hydrogen and neighboring acetate, and they will convert that into methane. And they are using this to create energy. So methane is just a waste product of these methanogenic bacteria. So after it leaves these methanogens, that methane is oxidized to CO2 either as a gas directly or through combustion, because methane is highly flammable. So I don't know if you ever watch The Princess Bride and they're in those bogs and you have the fire spilling out. That's not too far off the mark because this gas would certainly be flammable. Okay, so methane is the main component of natural gas. So when you turn on your stoves at home, most of what is in there is methane. And again, when that gas is burned, you're taking methane and combining it with oxygen, and when that combustion happens, you're ending up, releasing a lot of CO2 as well as some parts of water vapor. So when that methane is burned, large amounts of carbon dioxide are released into the atmosphere. Again, this sort of plays into the whole combustion thing, and that's really not so great for the environment, but we'll get back to that later. So organic materials are decomposed most of the time, but not all of them are going to be decomposed, right? So what happens to the rest of that organic material? So one thing that can happen is that it's converted into this stuff called peat. So peat is just a waterlogged soil that contains a large amount of partially decomposed organic matter. And so this is like a map of the different peat forests. You see they tend to be in sort of these northern extreme climates. And for whatever reason, IB is obsessed with talking about how this stuff is formed. So do know this process by heart. So again, peat forms because of incomplete decomposition. So this is stuff that was never decomposed by the saprotrophic bacteria or the methanogens, and then they get covered in some sort of water. And so once that water comes on the scene and they start getting buried in the sediments, it creates an environment where there is no oxygen, but then also the environment becomes very acidic. So it's these three components that are really necessary for peat to form, because especially these acidic conditions. So once the microorganisms like the methanogens that would normally decompose them die off, those energy-rich compounds are still there, but they're never decomposed, right? So over time, the heat and pressure causes that organic matter to transfer into these, energy-rich hydrocarbons, right? Okay, so that takes us to the fossil fuels. So if we start, and I did leave a little space on there for you guys to draw this on your notes. So if we start with these dead organisms, and like we say, only part of them was decomposed. And then I now have, say, these conditions where I have water-logged land where there is no oxygen, and you might see different versions of this vocabulary, either anoxic or anaerobic, whatever. It just means there's no oxygen available. And the environment is acidic. So you need all three of these in order to form peat. And you do have to know this, right? So waterlogged land, no oxygen, and an acidic environment. And after that, you will get some peat to form. And after peat, you know, this can either be burned directly for energy, or if it is further compressed under even more sediment and heated over millions of years, you'll end up with like your coal, oil, and gas. Although I think your book says oil and gas come from ocean and lake sediments, so that might make it different from peat. Okay, so we'll go ahead and move on to the aquatic, the water carbon cycle next.